So, yesterday we wrote down these couple properties for our metals, nonmetals, metalloids, right? So we looked at our periodic table. We have, hey y'all, hey, hey, thank you. All right, so we have the little stair step here. That's our metalloids line. All right, everything that touches the metalloids line is considered metalloid. Those have properties of both metals and nonmetals. Then everything to the left was going to be our metals, right? And everything to the right of that stair step is going to be our nonmetals. That's important for us to kind of get used to which ones are metals and not. All right. So what we're going to do, just so we have a little bit more room and it's something that you'll keep in your journal, is we're going to use that little half sheet that you guys picked up at the front. You taped it into your journal. We're going to write down the couple facts on this, okay? And that way you have this. You can refer to this during bonding and all that stuff, all right? So this is just more about the organization of everything, because basically it's not going to just be group numbers. We're also going to be knowing them by some of their family names, okay? So this is just all about periodic table organization. So on that page that's kind of facing it, okay, we're just going to write down a couple facts up here, and then we'll go back down here and we'll write in our group stuff, okay? So we know that the columns on the periodic table, okay, we have these numbers that are above them. We have numbers 1 through 18. What are those known as? Groups. Okay. They are also known as families. So go ahead and make sure that you have that part there as well. Okay. Families. Okay. So these will definitely have similarities. Does anybody remember why? Why are they similar? Valence electrons, yep. Similar because valence electrons. Okay, so it's all about how many electrons are on the outside. Okay. What was the easy way that we were figuring out your valence electrons on the periodic table? Kind of, yeah. So the group numbers, but they're the ones that have the little a attached to them. Okay, nothing, no double digits, because we can only go up to the number 8. Okay, all right. So, that's what I was gonna put. Sorry, valence electrons. So you can put a little a right there, just to kind of remind you that that's what you're looking for on most periodic tables. All right. So only our main group elements. We don't worry about the ones that have B, because they don't necessarily. We don't rely on their valence electrons as much. Okay, they still have them, but they have a little different stuff that goes on. All right, so they're valence electrons. So one of the ways that we communicate valence electrons, and you're going to definitely see for the rest of the year as well, is we use these Lewis dot structures. All right, so Lewis structures, so you can say that. That way when you see it and it says, hey, draw the Lewis dot structure, you'll know what you're talking about. All right, so a Lewis dot structure, pretty simple. Just to pick a couple random ones, I'll put something like, let's do magnesium. So magnesium is in group 2. How many valence electrons does magnesium have? 2. It has 2 valence electrons, right? So it has 2 valence electrons. Okay. It's a metal. So does that one form a cation or an anion? That was from yesterday. A cation. So remember, our metals form cations, okay? Meaning they have a positive charge. You'll kind of start seeing why. All right. I don't think I told you guys this little hint. The easy way to remember cation and anion is that cation has that T in the center for positive, and anion has an N in the center for negative. All right. So that's kind of an easy way to keep those straight. All right. Back to this, sorry. So it has 2 valence electrons. So when you go to draw your Lewis dot structure, you write your chemical symbol name, and then you're going to basically, there are 4 sides to each of these symbols. You guys see that? 4 sides. You're going to go clockwise with your dots, all right? So we got to show 2 dots, 1, 2. There's the Lewis dot structure for magnesium. And that'll be really important, especially, like I said, when we get to bonding, but I want you guys to already start thinking about your valence electrons. What this also kind of starts showing you is that since we know it has a positive charge, we know it's going to lose electrons. It only has 2 to give away. That's something else, right? So these 2 electrons are given away, so then it'll end up with a positive 2 charge. We'll write those across your periodic table as well, okay? But that's kind of where the similarities start coming in. All right, so let's choose one on the other side of the periodic table. So a nonmetal, we're going to go ahead and go with phosphorus. Let's do phosphorus. So phosphorus is in group 15. How many valence electrons does phosphorus have? 5. All right, so we're going to write 5 valence electrons. And then to draw those dots, again, I'm going to start at the top. I'm going to go 1, 2, 3, 4, and then end at the top, 5. So if you notice, we're kind of doing a very similar thing to when we were doing the orbital diagrams, the arrows, right? You give each one their own spot and then double them up, all right? It's not showing the exact same thing, but it's an easy way to think of it, all right? So 1, 2, 3, 4, 5. So there's 5 valence electrons. So as you can see, he needs 3 more to end up with 8, right? A noble gas is what everybody's trying to be like, which is all full all the way around, okay? So actually, I don't think it would be a bad idea. Go ahead and draw a neon real quick. Neon's in group 18. He's a noble gas. He's all full, so he's going to have 8 valence electrons. Put a star next to that, because that is the magic number, right? 8 valence electrons, so 1, 2, 3, 4, 5, 6, 7. Oh, I totally missed that side. 8. So 1, 2, 3, 4, 5, 6, 7, 8. All right, and that's full. So this right here, this is what everybody is trying to be. And that's kind of what gives most of these their properties, is that if everybody's trying to get to that status, then they're either giving away electrons or they need electrons and they're taking them from somebody, all right? Or we're going to see sharing happening too. All right, so anyway, that's a couple chapters ahead, so I'm not going to do too much more with that, but I wanted to make sure you know what a Lewis dot structure would look like. All right, the last thing we're going to write up here for now is going to be that the across things, we have numbers 1 through 7. What are those known as? Those are periods. And if you remember in electron configuration, we thought of those as energy levels. We're going to write that again because we're going to see that energy levels we're going to be thinking those like layers. Layers. I'm going to write that word that way. There we go. So layers. Okay? Doing okay? Yep. Sweet. Thank you. Thank you for your response. All right. So let's go ahead and put in some of these family names. We're not going to take too long with this. I'm going to turn mine sideways. That way I can just write and not have to worry about writing at an angle. Actually, I'll write at an angle. I'll write at an angle. All right. So for our first group, okay, first group, these are known as our alkali metals. Okay, so group 1, alkali metals. Okay. Is that better? A-L-K-A-L-I. Alkali. My A got chopped off. There you go. Alkali metals. All right. So our alkali metals, these are our most reactive group on that side of the periodic table, right? Group 1s. So earlier I had them just put a little star up here and a star down here to remind them that this is reactive, very reactive, okay? All All right, so I got to show last period this, so I'll show you guys as well real fast. So when we say that they are reactive, group 1 items, when you drop them into water, will catch on fire. That's why we actually don't find these necessarily in nature, because they're so reactive with something like water, which you would think shouldn't, right? And so these we usually have to pull out of things that contain them to get a pure sodium substance or pure potassium substance. So this was the little video that I had shown. I'm going to make it go just a tiny bit quicker because I don't think we need to do it. Oh, no, we'll go 1.5. Okay. So there's not really talking on it, but you can at least get to see some of this. So you notice they said alkaline metals, but some resources right, okay, but alkali metals, okay? So lithium, we're at the top of group 1. Lithium, it catches on fire. He just put it into water, all right? He dropped a pure piece into water. Sodium, so we're moving down. We're on that next row, okay? So this one, you're going to see it looks pretty similar, right? But then it's going to become a little bit more vigorous because it's going to kind of start doing little explosions and then starting over and things like that, okay? Then he puts a piece of sodium and he drops water onto it to see what happens, okay? And that's what's going on, all right? That's why I usually don't find those in nature, all right? If you dropped a huge chunk, okay, so some of this is a little dramatic, but it's kind of cool. I feel like I would be that neighbor. It's kind of neat. Okay, so who's next? Potassium. Potassium, we're going to see what potassium does. All right, there you go. All right. If you've ever seen Percy Jackson, the Lightning Thief movie, that's the whole part of the beginning in the pool. He put potassium into the pool. That's why it exploded. Okay. So cesium, that one breaks the whole thing. So you're kind of seeing these are getting a little more intense as we're moving down the periodic table, right? Francium, we actually don't have a video of that one because it would be so huge and terrible. So he just puts that. But anyway, that's the whole idea. All right. So they gradually got more reactive as we moved down the periodic table. Okay. So that's what we mean when we say that they're reactive. It's not just boring and, oh, okay, it smokes. Yay. Like, no, it catches on fire and water. All right, let's move on to the next one. Group 2, these are known as our alkaline earth metals. Alkaline earth metals, that's group 2. All right, so these guys are also reactive, but it's not as awful. We can find these in nature. Okay, so alkaline earth metals. All right, I'm going to turn my paper normal. This center section, right? So this was like our D sublevel in the last chapter, right? These are known as our transition metals. Transition metals. These, even though in the flame lab we had used a lot of people from group 1 and 2, you did get to see copper, which was over here. So these tend to be colorful. Like when we put them into solutions and things like that, we have a little bit more color when we're dealing with our transition metals, okay? But we don't really say anything about their valence electrons. We don't really say much about, they don't have a special name for each category, okay? All right, so those are our transition metals. Then in group 13, 14, 15, 16, super boring, but we're going to write them, okay? 13 is going to be the boron family. Group 14 is going to be the carbon family. You see where we're going with this? Group 15 is going to be the, no, it's phosphorus. I'm just kidding. It's nitrogen. It is. Nitrogen family. I don't know how I ended up writing almost upside down. That's okay. And then O, or the group 16, is our oxygen family. Okay. And then finally, group 17, I think we wrote who those are in our notes. Those are our halogens. Halogens. All right, so halogens are the other super reactive side. Okay, halogens. Halogens. So you might put reactive again. And then finally, 18, those are known as our noble gases. And those are the stable ones that usually aren't bonding and usually aren't reacting. I shouldn't say usually, always aren't reacting. Sometimes they bond. Every once in a while when we get lower. Okay, so noble gases, that's our, I put a smiley face there because those are the ones that everyone is trying to be like. Okay, all right. So I'm going to turn my page back normal. You guys all got those? Those are your group names. Oh, wait. Okay. So remember the whole point of these groups, right? The whole fact that they are families, they have similarities. We said had to do with valence electrons. So all I'm going to do is I'm going to circle all the parts that have A's. That way when I go back to look at this later, I know what my valence electrons are. And that kind of tells me how many dots to put, right? We drew a couple examples. So remember, the dots come from those A's. All right, I'm going to turn my page to normal. The last thing I would like to go ahead and just start putting here, it's not something we're going to use yet until bonding, but I do want you to be aware of it. So if we have our situation, like our charges, okay, so whenever we're talking about the charges, we know that positive ones are going to be called cations, negative ones are going to be called anions, right? So metals, those are positive, nonmetals are going to be our negative, right? So it all has to do with those valence electrons again. So if I had something like calcium, okay, calcium is in group 2, right? So how many dots is the Lewis structure going to have? 2. So we're going to have 1, 2. So I have calcium right there. If I have somebody like oxygen, how many dots does oxygen have? 6. Look again. All right, so don't confuse it with the atomic number, right? You're looking at the very top of the column. There's 6 right there. So it would be 1, 2, 3, 4, 5, 6. Right? Okay. Remember, everyone is trying to be like neon or argon or any of those in there, right? So if that is our ultimate goal, I'll just go ahead and write argon. 1, 2, 3, 4, 5, 6, 7, 8. If everybody's trying to be like argon, what is calcium's plan of action? Do you think he's going to look for 6 other electrons, or do you think he's going to just give away his 2? Give away his 2, yeah. What about oxygen? Is he going to give away his 6 or take 2? Take 2. Do you see that if I have less electrons, like if I am lower on the number of valence electrons, it's easier for me to give them away. Hence, we have a positive charge. And this will be a, sorry, I'm going to specify this is going to be a positive 2 charge. Okay? You do not have to master this yet, but write it for now so that we can come back to it. So this will have a positive 2 charge. Oxygen, we said it's easier for him to take on 2. So it's going to be a negative 2 charge. That combination is a happy family. It's going to be, they're going to bond, okay? So that's what's coming, not in this chapter, it's in the next one. But I wanted you guys to just be aware of like where it's coming from. It's coming from those valence electrons, right? So you can go ahead and write above all of these, just a couple of those charges in. So we're going to have like a +1 for our whole group 1. We're going to have a +2 for all of group 2. We're going to go across the way. We don't even worry about transition metals. They have weird rules. We're going to have a +3 for group 13, right? When we get to 14, we actually have +-4. I'm not going to write it. I'm just going to save my hand there. And over here, we're going to go ahead and start looking at, okay, so once we get here, it's easier to take on 3. So that's a -3. This will be a -2. This will be a -1. So you guys kind of see that happening. And that's going to really help you to see how they're going to bond. that gives them their properties. Okay, it's how much they want to bond. All right, what they're going to turn into. All right, so that's all that we're writing on this page for now. Does anyone have any questions so far? Like for a charge, since they don't really bond, we're not going to put that necessarily. You could put a 0, I guess, but 4 is going to be a plus or minus 4. So I would just hold off on putting that for now, just because technically once you get below group or period 3, these all have multivalent charges. So it's weird. So, okay. Alrighty, cool. So that's all I wanted you guys to write in there. So what we're going to do now is, did you guys finish your ed puzzle already? Some of you did, some of you didn't, right? So I'm gonna, okay. So there's a good chunk that haven't, all right? And I'm recording this for afternoon classes real quick. So you guys are going to go ahead and go to Schoology and knock out that ed puzzle. Make sure it's done, okay? I will hand you guys one other thing that we will potentially start. But I want you to knock out the ed puzzle first, okay? All right.